We're recording, and let's pull up the workbook. So we had just done some like card questions. We will definitely do card questions again later. We did a dice question. We're going to do more dice and coins and stuff. But really, all this chapter 5 stuff is supposed to be basic math. I've already like done up till I think 5.4 on the homework, like by myself, and it is all multiply and divide and add and subtract the whole way through. It's just more so like which ones do you do? Anyway, so I'm going to remind you of my formula of the day, of every day. Your probability, probability. I think no, I didn't spell it right. Come on, Chad, spell something right. Probability, bill it. Okay, can y'all like yell at me and say like, "Hey, Chad, you need to actually spell." Probability is equal to selected over total. Selected over total. That's your big formula of the day. Every day. I literally use that all the time. Cool so far? So let's do it with the coins. So we have one coin, and I'm flipping it 4 times, and I want to get at least 2 tails. What's the probability? And so they list out all of the different outcomes, I guess you could say here. And I want to know, does it have at least 2 tails? And so at least 2, what does that even mean, right? It means 2 or 3 or 4, right? All tails. So let's go. Does this have at least 2 tails? This one right here. Nope, not that one. This one. Does it have at least 2? This one? This one. Ah. And so that's one of my selected. And you see how I'm going to go down the list? So no, yes, 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 no, and then yes, 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 and yes. So I'm going to count up how many I have selected. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 selected. And what's my total? 16 total. Basically, at this point, I'm just going to go to like Desmos and put that in. So 11 over 16 is that much, and we're done. Like, that's the entire problem. My math lab wants to go back and forth a lot. They'll say like simplified fraction, and then they'll also say decimals. So like, what's the if they wanted a simplified fraction, what would be the answer? Well, it's 11 over 16. So like, that's also another answer. It kind of just depends on how they're wanting it. Are y'all okay with that? Cool, cool, good, good. Okay, awesome. Next one. You roll a pair of 4-sided dice. So, okay, 4-sided dice is 1, 2, 3, 4. That's it. That's what they're trying to say. So list all the possible sums that will make it a 7. So, okay, here's the thing. I got, let's say I roll the dice and I get a 1 and I get a 1. And so that when I add them, I get a 2, right? But I could also have like a 4 and a 4, and that would make an 8. And so, and there's all the stuff in between. How can I actually get down to the root of how to get like 7s? So here, let me make this table for you. And so you don't have to do this, but this is the easiest way. 1, 2, 3, 4 on the first roll, and 1, 2, 3, 4 on the second roll. And all I'm going to do is add up whenever they match up. So for example, 1 and 1 will make, will make a 2. So I put a 2 right here. 1 and 2 makes a, and then 1 and 3 makes a, and then finally a 5. You can see there's a pattern here. 2 and 1, 3, 4, 5, and then a 6. Start over. 4, 5, 6, and 7. Start over. 5, 6, 7, and 8. You don't have to do it this way, but I think it's the easiest way to do this. So far, is that okay? Well, out of all these, out of this huge list, I want to do the selected over total. How many 7s do I got? 2. 2 selected. Out of how many total would I have right here on the inside? 16. 4 times 4 is 16, right? 16 total. And so I guess that's like 1/8, or again, decimal wise, again, they're going to go back and forth all this time about decimals and fractions. There you go. Cool? Yeah. Okay. So you don't have to do it that way. I mean, some other options would be like, well, what would make a 7? And as long as I have it no more than 4. So I've got like, would 4 and 1 make a 7? Would 4 and 2 make a 7? Would 4 and 3 make, but not just 4 and 3, but also 3 and 4, right? So those are the two options to be able to get 7. So you could say, oh, I've got 2 selected out of 16 total. Cool? So a couple different ways, but any questions on that? Okay, cool. So this one's a little bit weird. It says determine the sample space of blah blah blah, and I think it's a little bit weird. I want to do this one, and then I want to see what y'all come up with down here. Okay, so let me start at the top, and then I guess for the first time I could start having you do's. See, I do, you do, we do. I know it's a weird concept in statistics, but hey, here we go. So what does a sample space mean? Let me help you on this one. They're trying to group all of the possibilities. So we got Yolanda, Michael, Kevin, and Marissa. The unfortunate problem is that we have two M's. Okay, so if you don't mind, what I'm going to do is, well, I'm going to change her name. I'm going to just call her Arissa. Is that okay? So that she's an A, so I can use A instead of M. I know, whatever. So we got a Y, we got an M, we got a K, we got an A. So to be fair, we're selecting 2 people that can go. Let's list out all the ways 2 people can go. We got Yolanda and Michael. That's easy. Yolanda and Kevin. And then we got Yolanda and Arissa. Cool so far? Okay, cool. Next one, we got Michael and Yolanda. Like I'm going backwards here. Wait. Didn't we already have that combo? We don't need that again. I got Michael and Kevin. That's a new one. And then we have Michael and Arissa. And then I'm now at Kevin. So Kevin's the first one. Kevin and Yolanda. But wait, didn't we already have them together somewhere else? So I don't need them again. Kevin and Michael. But didn't we already have them together as well? So I don't need them either. Kevin and Arissa. We haven't had them yet. And what you're looking at now, that's kind of like all of the different possibilities without duplicating anything. Okay, so like if I had to list them all out, it would be the YM, YK, YA, MK, MA, and then KA. There we go. 1, 2, 3, 4, 5, 6 total, I guess you could say. Cool with that? With that knowledge, I want you to answer the bottom 3. This is a you do, and we have these so rarely in this class. But finally, I want you to try this out. I want you to do it for a minute and see what you get, and then we'll talk about it. Until then, I can do math ASMR. That's right. You're doing it so good. Keep doing it. B, C, and D. Yeah. See you later. Have fun. Thank you. You're doing great math. It's great. You're doing great math. Have y'all ever like watch / listen to ASMR videos? No. Yeah. They're kind of funny, aren't they? Not my thing really, but maybe I can make them. I can get the squeaky marker too, right? We can do that. Like, no, that's not good ASMR. No. That's not what I'm wanting there. Okay, let's do like 10 more seconds. And you don't have to finish. I just want to see, did you go in the right direction? You thinking about this in the right way? Here we go. So it says compute the probability that Michael and Kevin are going. So I want Michael and Kevin, and that's it. Michael and Kevin. Michael and Kevin, MK, right there, MK. So how many selected did I have? It's selected over total. So what was my selected? 1. What's my total? 6. So answer was 1/6, right? Easy. What's the probability of Arissa going? Again, I have to say Arissa for this one. So Arissa, there and there and there. Hello. So same as last time, we got selected over total. What would be my selected? 3, right? Because Arissa. 3 of them. Like I'm looking for where there's an A. Cool. Out of a total of 6 once again. 3 over 6. Doesn't that reduce down to something? Perfect. There you go. Boom. Right as you're coming in. You got it. And so it says interpret what's going on. If we did this 1,000 times, how many would result in Arissa going to the concert? So this is the interesting thing. We got 1,000 and we got this half. So half of 1,000 is how much? Done. And that is the answer they're wanting right there. And that's it. Cool. So we did a you-do finally. Yay. I know, right? Oh, I know, right? Yeah. Yeah. I had to do that on mine so that I could make it work, but so I have on my, see, I go through the homework before we come to class, and I have another homework question at the bottom here, and I want to put that down here as well. Okay, it might go to like the next page, but it's a very short one, but I still have to talk about it. So here we go. This is homework number 6, at least at the recording time of this video. It says flip a coin, and you're going to roll a dice, and it says, what is the sample space? And I'll probably pull this up later when I pull up the homework. But let me tell you, this was like a very confusing problem. I did not like this problem because it was just weird. So let me show you what I'm going to do here with this. Hold on, let me show that. Okay, so yeah, here's the answer to this. Correct. So okay, we got 1 through 6, and for the coin we have heads and tails, right? This is how they want the answer. I'm going to write it out. This is going to be very annoying. You can get heads in a 1. You can get heads in a 2. You can get heads in a 3. And you can see that I have to do all of this. Heads in a 5, heads in a 6, and then we can get tails in a 1, tails in a 2, tails in a 3, all the way down. And yes, hey Chad, do I have to type all this out for my answer? Yes. Yep, all of this, literally all of this, is your answer in MyMathLab. This is what it looks like. So it's not a hard problem, but it's like really weird. I didn't ever see another problem like that. That was the only one that was like just off the wall. But I wanted to just tell you about it before we get there. Cool? Okay. I had to get it wrong 3 times to see like what was the format. Like what are you looking for? Do y'all ever do that? Get it wrong a little bit to see what they have? Yes. Recommended on this one, let me tell you. Whew. So any questions on this? So far so good? Awesome. So part 2, empirical probability. Let me give you the Chad definition because I think it's going to be way easier that way. I call this stuff, we're going to be looking at charts, at graphs, at plots, at tables, etc. You're going to be seeing a lot of numbers like this. I would say the best way is a not fixed probability. So this is different than coins, cards, dice. This is different than that. So this is more like, let me give you some other examples. Probability of raining. So it's not fixed. Hello. batting averages, like for baseball and stuff like that. Probability something of touchdowns or something like that. So like sports, things that change over time. Okay, so that's what we're looking at here now. And again, every single time I'm going to remind you, probability is equal to selected over total. That's our big formula every single time. We're using it on every problem. Cool so far with that? So charts, graphs, plots, tables, something that's not fixed, like baseball stats, football stats, just, all these kind of things that happen just throughout the day. All right, so they're asking right now, is it classical? Is it fixed? Like, cards, dice, and coins and stuff like that? Or is it more like statistics that we're like learning and changing all the time? So you toss a fair coin, what's the probability of heads? First off, which one is this? Is it classical or is it empirical? Coins. Fixed. Classical. Yep. Classical, fixed. And we can even find out what this probability is. And it says, what's the probability of a heads? That's kind of easy. What is that? Yeah, 1/2. Yeah, that was it. Yeah, pretty easy. Cool. It says now you do it 100 times and you get 52 heads and 48 tails. It says based on this experiment, like just right here, what's the probability of heads? Now again, remember that we're going to be doing selected over total every single time. So what would be my selected for heads? 52. And what's my total? Perfect. Yep, exactly. And so this one comes out to be 0.52. We can do that on the side, of course, but 0.52. That's their answer for this one. So the original was 0.5, and now there's 0.52. This is how the homework is. This is like a homework question. You'll type in 0.5, and they're like, oh, well, now it's changed a little bit, but it's really about 50%, really. The idea that they have for this is that over time, and this is the over time thing, you might have a kind of weird and sporadic, like, oh, I'm getting a lot of heads. I flipped 3 heads in a row. It's always heads. But eventually you'll get tails, and then you get more tails, and it'll kind of level off eventually. So that's what they're kind of saying here. Cool? Okay, I have something else written in my notes here. It's another one from the homework, okay? So, I put 3 stars on this dude, okay? Here we go. So this is like 3 stars. So on homework number 13, again, at the time of this recording, I'm going to write down what I have here. It says once had to use. Okay, yes. So you have to use graph, chart, and then columns. And when you're in there, you have to select aggregate proportions. Aggregate proportions. When we come to the homework side, and I'm doing the homework here in a few minutes, I'm going to show you this. But this is all StatCrunch, and it's for this one problem because they're going to ask, what does the graph look like? That's it. You go here and you're done. Okay, so StatCrunch, graph, chart, columns, aggregate proportions, and then you get this graph and you're good. Okay, it's a 1-question thing and you move on. But now you have it written down, so that you have it written down. Is that okay? Cool. Any questions on what I wrote because my handwriting's so terrible? It's true, isn't it? It's pretty bad. Well, I say so. No? Is yours worse? Oh, of course not. That's funny. Okay, keep cruising then. Keep cruising. So suppose a survey has 500 families with 3 children, and they found that 180 have 2 boys and 1 girl. So they're wanting to know what should it be and what are we actually getting? What's the difference? If you think about it, they're doing 50-50 basically. Which one are we doing here? 1 girl, classical method. Okay, so this empirical method, we're just going to take selected over total here. Oh, thank you. What would be the selected? What would be the total? Just looking at this kind of stuff right here, just Give me some numbers. Select. Yep, 180, and then the 500. I mean, it's really like you only got two numbers, and you need a selected, you need a total, and it'll always be smaller in the top. So they're asking, what's the probability of having two boys and one girl? They say 36%, according to the numbers. But like, if you think about it, it's like equally probable for one or the other. Like it's a 50-50 shot every time, right? It's kind of like heads tails. So what would it actually be in real life? Not just from this study, but like in real life. And so what I did, I went through and started listing them all out. So here we go. We got boy, 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 right? Because we're talking three kids in a row. We got boy, boy, girl. We got boy, girl, boy, and then finally we got boy, girl, girl. Okay, and let me keep going to the next slide. So then we got girl, boy, boy, girl, boy, girl, 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 boy, girl, girl, girl. And they're asking, what's the probability of two boys, one girl? Two boys, one girl? Do I see another one? Two boys, one girl? Is there anything else? Is that it? Yeah, B right there. You're right. There it is. I can't read my own handwriting. So what do I got here, right? Did I mix them up? I think I didn't do them all. I feel like there's more to it. Let me look at my paper right here. No, that's it. Okay, cool. Oh, I was not looking at my thing right there. Hold on. Boy, girl, boy, 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 girl. Yeah, that's fine, right? Did I do it right? Did I forget something? Correct. They're saying in a particular order, like the oldest, youngest kind of thing. And so, where's the girl? The girl's either the youngest, the middle, or the oldest, right? And that's essentially it. Is that the whole possibility though? Boy, 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 girl, boy, all that kind of stuff. So, anyways, what we got now is three selected. But what would be my total? Like, what's my total amount here? I got eight, right? Eight of them. Yep, eight of them would be my total. And so then my answer would be 3/8. Or if I go to the calculator for that, 37. Basically 37 or 38 percent. And we had 36 when we actually calculated it. So I gotta admit to you something. I did it wrong on my paper, and that's why I was confused. I'm looking over here. I only selected 2 out of 3. How bad of me! That's how bad I can't even read my own handwriting. So it's 3 out of 8, and so I got 375. That's why we all work together. Is that okay? Cool. Any questions on boys and girls? Oh, here we got another part. Okay, so it says according to this, if you did it 1,000 times, how many times did you get it? So really, again, we just had this, and we multiply them. So all I'm doing here is the 375 times 1,000. Do you know how much I'm going to get? 375. I'll prove it to you. 375 times 1,000. Yep, exactly. Move it 3 places right. You got it. That was 100% true. There it is. Cool. Is that okay? Kind of a little weird, but I mean, we're learning about, I guess, 50-50 shots of probability. Yeah. So, what I want to do here with any questions before I move on? Are you all here? You good? Okay. So I want y'all to do this one. This is a you do. And I don't get to do this very often. Sure. Yeah, go ahead. You're good. I can leave it here as long as you like. I don't get to do a whole lot of you do's in this class because it's all stat crunch and stuff. But I want y'all to try to figure out the next one. I want to see if y'all can come up with something. It'll be fun. So if you have a workbook, you can already see what the question is. The Army question. And in the meantime, I can talk into your ear very soothingly. Did you like and subscribe today? Yeah. Well, I guess my notes down here are wrong too. Here. Okay. Good. Let's scroll a little bit. Just that. So yeah, that's a you do. I'm gonna wait another like minute or so. I want to see what y'all come up with on the Army question there. Oh, that's a good one right there. You're doing great math today. Yes. It's a Thursday too, which is really cool, right? Thursdays. I'm gonna go for like 10 more seconds. 5, 4, 3, 2, 1. All right, here we go. So I want to see. I'm gonna do it, but I want to see if y'all got what you got. You know what I mean? It says probability single parent United States military Army. Really, the main thing here is just Army. What's the probability Army? Well, we always go back to our formula. I want selected over total every single time. So my selected for the Army, what would that be? 35, you got it. And then my total would be 100% true. The probability of you getting this right is 100%. So there you go. Of course, I'm typing it wrong. And there we go. You put it in the calculator, and we get some numbers, and you're done. It says nearest hundredths. That's only 3 decimals. What is that, like 406, basically? So there we go. That was it. That was pretty easy. It will get more complicated soon. They don't have all those numbers there for nothing. They will start asking different things about it. They'll say, hey, given that you have a male, or given that you have a this or that, and they're going to change it up a little bit, okay? But for right now, we're just keeping it simple. Cool? I'm going to keep cruising. Did y'all get what I got? Cool! Yes! Okay, so let's see the next one. Okay. Is that... Oh, it says it wants the probabilities of that stuff. What's up? Did I do something wrong? Oh, hundreds is 2 places. You're right. Well, it looked good. Oh. Yeah. I messed up. You're right. So, my math lab would have told me something, right? What would it have done? Come on, say it. Oh, it wouldn't have said that. It went. Sorry, you're right. I messed up. Thank you for pointing that out. And continue, like early on. Don't believe me. Do I look trustworthy to you? Do I have to take the name tag off? And then, okay, I'm taking the name tag off. There it is. That way I'm not trustworthy anymore. Do I have to get rid of my tie? My tie making me look trustworthy? Oh, okay, I'm going to keep it where it is then, okay? Yeah. There it is. Take my name tag off. Now I'm not trustworthy anymore. I had to rip off my tie in one of the classes. It was crazy. Oh, you're good then. You're good. Okay, so this one, it just says, hey, fill in these probabilities. Well, every single time it's selected over total, but what I don't have is the total. I need to go and find out what my total is going to be. Yes, it's like right there, right, TechCrunch, and you can, and that's totally cool. because it's kind of small, I'm going to just add them up right here. But yeah, StatCrunch is definitely viable for finding the total there. So I've got a 1,039. And what I'm going to do is just select it over total every single time. First off, I got the 126 over the 1,039. And I'm just going to go one by one with this. 1,039. 12127. And it says 3 decimal places, just in case I, mess up now. It's pretty clear. Are y'all okay going one by one, dividing these guys out? I just want to, of course, get these down for your notes, but ultimately this problem's pretty straightforward and easy. And I am going more than 3 decimals so that you can round it. Because y'all are good at that, and apparently I'm not. Okay, last one is the 388 over the total. Oh, well, there you go. 388, 1039. And I got 37344 technically. There you go. All right, so there's your answers. And then they're asking this part. It says, is it unusual for 18 to 79? So they're just saying the top part right here. They're saying this number right here. Is it unusual? And I'm going to put a question mark next to it. And what do y'all think? Do you remember what unusual percentage is? No? I'm going to 5%. Very good. Yeah, so that's the 5% cutoff line. Did I reach 5%? No, that's more than 5. So I would say not unusual because it's more than 5. It's more than 5%. Yeah, 5% is the cutoff line. 95% of people are usual, are normal. Yeah, now you know that. But 5% are not, apparently. So there you go. Cool with that? It's just a true-false statement on the homer. Pretty straightforward. And then lastly, number 3. So subjective probability. I'm going to just give you my chat answer. This is what I would say shooting from the hip. That's an old term. Shooting from the hip. Do y'all ever watch Westerns? Okay, so it's like an old school thing, but like, the cowboys will pull out their little pistol and go pow, 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 pow from the hip. They don't know what they're hitting. They're all over the place, right? And it just looked cool. So that's like, it just looks cool. I'm going to do another one. Good guesses. Good guesses. And it's just you're guessing. And I'm going to give you this question, but I have my own as well. So shooting from the hip or good guesses. So it's saying, like the statement that we have here, that past 8 seasons, baseball player home run hits, we got 6%. Okay, so first off, I just want to know which one is this classified under, and I'm going to remind you, classical is fixed. We got like dice and coins and stuff like that, and then we got this empirical, which is more like data and charts and stuff like that. Tables, and then the subjective maybe. So which one would you say this is? 6% for home runs. Would this be classical, like coins and dice? No, that doesn't make sense. Yeah, it would be empirical. So basically, yeah, we got these two guys here. So definitely empirical, because like data, and yeah, based off observations obtained from an experiment versus the results of an estimate. Are we estimating this? No, they're actually counting how many, right? So that's wrong. It's definitely D then for sure. And literally that's the end of the section. I don't feel that's enough for the subjective. So I'm going to make my own, and it's kind of like from the homework, but it's just a talk about it question. Okay, so I'm going to do one more little tiny one right here. So here's another example for you, okay? It says doctors say that you have a 20% chance to live. I don't know, versus a procedure or something like that. What would you call that? Is that classical? Is that empirical? Are they gathering data? Or are they just kind of shooting from the hip at 20%? Shooting from the hip. That would be a subjective probability. You go into a dentist and they're like, well, 80% chance you're going to have a cavity. Are they really getting that like specific, or is it maybe like 79.2%? You know what I mean? If they'd say 80 or 20, it's kind of just such a broad number. You're like, yeah, okay, you're just saying a number, rather than actually giving like data like right, exactly 50-50 chance. It's just kind of like, I don't know if I believe that, but that's just personal. Yeah, they're not making it completely wild, but it's not 20. Maybe it's 18.782165. You know what I mean? But they're not going to say that, so they just say 20. Cool. Cool. So there's another example, and we're done. So I want to go to the homework for this, and I just want to show you around. I've really had no issues really with the homework in chapter 5 so far, and I've already gone almost the whole way through. So I just want to do a show and tell. Not a big deal. And then we'll go back to the workbook here in a few minutes. In particular, I want to go to that number. Was it 13 or something? I can't remember. Number 13. I want to show you that one with the stat crunch, okay? So that'll be here in a minute. Hey, guys, look, question 1. Boom. And you know what this reminds me of? It reminds me of the very first stuff in this, definitions in this section. See, they say, hey, guess what, guys? Chapter 5, we're going to do cool math. Never mind. You remember filling in all that stuff? So, okay. I'm not going to go back through and fill in all that stuff, but I can tell you something about this here. You can just start clicking the top answer, and the top answer, and the top answer, and the top answer. Yep, because this is what I had to do to find all those answers in the workbook. So they're telling you what it is. Then I said, aha, and I went back to the workbook and I filled in all the blanks, and then I was like, okay, there we go. But I already talked about that last time. But now, are y'all worried about that problem? No. You can get that done eventually, right? So I'm going to move on. Let's do some more mathy stuff. So again, we got some multiple choice. I'd rather just keep moving. This one's pretty good. I have to say, the first thought, oh, look, stat crunch, boom. But hold on. I don't think we have to go that far right now. In all of chapter 5, I used it maybe one time, okay? And I'll show you that today. What are they asking for? They're saying, is this going to work? Is this a real probability model? And so the two options that we need, the two things are, they need to add up to 100%, and each one of those have got to be like a positive number. So do these add up to 100? That's the main question here. Yep. Exactly. So I'm going to triple check it. Even a 0, that's kind of weird, but if it's there, yep, yeah. So the whole thing equals 1. So that's good. So I would say, yes, it does, because 1, the sum is 1, and they're all greater than 0 and 1. Let's just pick the longest answer, you know what I mean? And then they're asking about green. And so green, it's 0. Which one would be the best option for 0%? Yeah, see how green is 0? What would I put for that here? Impossible. Unusual indeed, but even more it's impossible. But you're correct. It's actually unusual as well. It's both. But yeah, impossible because of 0. Yep. Cool. Keep cruising. That's an interesting question. Which of the numbers could be a probability? Again, like think of it like, what's the chance of raining today? 30%, 70%, that kind of thing. So could I have 0% chance of rain? Might that guy? Yeah, that's true. Can I have a negative chance of rain? No, I ain't including that. 32% chance? Sure. 6% chance? 115% chance of rain? No. And then can I have 100% chance of rain? Sure, technically, yes, yeah. And there you go. That's all they want, yeah. They just want to list out the ones that actually are okay to use. Yep, that's it. So not too bad in the end. It's a little confusing at times, but so I think we already talked about this one in the on the homework. Yep, this is that crazy one. So we got a spinner and we got different colors. Are they talking just black and red? Okay, yeah, cool. So remember how it was the heads, tails? This one now is the black, red one. So we got black 1, black 2, black 3, black 4, black 5, black 6, and then we got red 1, red 2, red 3, red 4, red 5, red 6. Yeah. So I had the heads, tails one. They have like black and red one. So either way, is this okay? We're not worried about that, right? And if you ever get confused, get it wrong, see what the format is, see what they're wanting, and then you can go from there. Let's see what else we got. Yeah, we talked about that one. Let's see if there's something else. I think this one's not bad. I want to see what y'all come up with here. You help me a little bit. So we got a bag of tulips, 100 of them in there. It's not too bad. And it says, what's the probability of a red tulip? So again, I want selected over total. What would be my selected for red tulips? How many reds do we got? How many? 30. What's my total? Awesome. So let's try that out. It says do not round. Okay. Cool. So purple. How many purples we got? 30. Out of? Cool. I think they're gonna like, yep, the same thing. And then they say if you're gonna do this 100 times, then what would it be? So we got 100 tulips without replacement. What's the difference here? Exactly versus about. And so I'm going to say about because it's never perfect. If I said that number, that 0.3 times 100, which kind of funny, back to 30 again. And the same thing with the other guy, right? Okay. I think the main thing is that you don't want exactly, you want about, because what they're doing is they're taking a tulip, looking at it, putting it back. Shuffle. Grabbing one, looking at it, putting it back. So you're not going to get a perfect 30 if you keep doing that, but it should get around 30. Is that cool? It's just a little word game. That's why I want to bring it up, because, like, what are you wanting from me here, right? We already did this one. It says relative frequency. That's just, divide by the total. We've done that 100 times already. I'm not going to move on. Or I'm going to just move on. This one, same thing. You're going to find the total and just divide each one. We did that on the workbook. Do it all the time. You could use StatCrunch, but I probably didn't. Oh, we talked about this one in the workbook. Let's do this one together. This one's not too bad. So we got D, R, C, M, J. They all have different letters, so that's cool. And they're taking 2 employees, and they want to know what would be the combinations that we have. So out of those, which one would be 2 letters, but having everyone included? What would you choose here, in a way? Can I say what I would not choose? They're saying, like, each person, I could have R and C, R and M, J and M, C and J, and all this kind of stuff. Well, you can't have R and R, right? So that doesn't make any sense. And this one's way too short. It's only the D's. I think this one's way too long. So yeah, I'm going to choose A. Yeah. Okay, so... And that's okay, because they would have said no, and then you choose A, right? So... Oh, yeah. Hey, that's often the answer. So it says, what's the probability of M and J? So I'm looking around. I want M and J, right? That's what it said, M and J. Where's my M and J's? M and J right there. So how many times selected? What's my selected for M and J? How many times did I select them? One time. Out of, what's my total here? Is it 8? 1, 2, 3, 4, 5, 6, 7. Yeah, 9. You're right. It's 9. So 1 out of 9? Let's try that. So 1 out of 9. Put it in. 3 decimals. Oh, did I do it wrong? Is there a JM? Marco and John. Marco and John. Is there a J, like a JM? Did I make a mistake here somewhere? 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 10. Oh. No. I thought it was 9 also. There you go. Okay, now it works. Okay, so what's the probability of R? So now we're going to R. We got an R right there. Got an R right there. R. 4. Are there 4 then? 4 out of 10? 4 out of 10. Cool. C's probably going to be the 4 out of 10 again. I'm just guessing here. What? Oh. No. Okay, so C stays home. So that means not C. It means not C. 1, 2, 3, 4, 5, 6. So 6 out of 10. Okay. Well, they're trying to get us. Yeah. It happens to me too. This is just multiple choice. I don't even know what I clicked on it. I thought it was silly. Oh, here we go. Is this number 13? Let me triple check here. Yup, this is it. All right. As soon as I saw that aggregate, blah blah blah, I was like, uh-oh. So this is for the for reals, okay? If you're gonna pay attention to StatCrunch at all, this is the moment right here. So they have a whole bunch of data, and I mean, look, if it takes that long to load, wow. Look at that. I want to go through this whole problem with you slowly. Do you get me? Because this is one crazy problem. Yeah, exactly. So yeah, this whole thing, here we go. After this, we go back to the workbook for a few minutes. Okay. So, yeah, they got a lot of stuff going on. And let's try to figure this out. It says, consider the first 10 days. What proportion of days had a train present? They're saying the first 10 days is like this stuff right here. And they're basically looking right here at this number, at this aggregate train. Aggregate means add it all up, basically. So they're saying, how many trains did we have here? If you look, we got 1 and we got 1 right there. You see those 2? So basically, you just look down here at this number, and it's going to tell you how many trains. 2. Okay, so I'm telling you right now, I'm recording it. It's 2 right there, 2. What? Consider? What's the... Oh, the proportion of days. Oh, we had 2 trains out of, I have selected 2, out of a total of 10. 10. So, silly Chad, let's try that again. Yes, exactly. So yeah, we had 2 out of 10. That's what they were wanting. Ooh, they got me. Now, for the first 20 days. So again, I'm highlighting all these 20 here, but really I'm just looking at that number. 5. 5 out of what? 20 this time. 5 out of 20. 0.25, 1/4, like you said. Okay. Were you stopped by a train on the 30th day? Okay, let's go to 30th day. 30th day, right here. Was there a train? It's a no. No trains. Okay, all 200 days. What's the proportion? Okay, whoa. I got to go all the way down here. 40. They're saying there's 40 total trains. 40 is my selected. But what was my total? 200. Very good. So 0.2. 40 over 200. All right, cool. Let me, I have to scroll for this one here. So they're saying, which of these graphs make sense? Are we on like the last part of this problem? I think we're almost done with this. So this is that part where I said we need to go to the graph, something chart, something columns. Let me just remind myself. Graph, chart, columns. So graph, chart, columns. This is how I did it. I mean, there might be another way, but this is how it worked for me. And then I chose, I think it was aggregate. Go ahead. I went graph, chart, columns. Yep, graph, chart, columns. And this is where I can't remember, but aggregate proportion, I think this guy. And I'm just going to hit compute. I think that this is going to work. It is, but here's the thing. Without doing a lot of extra work, kind of tilt your head to the side. Tilt your head to the side. Do you see how it spikes? And it spikes again, and then it kind of goes jigga, 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 jigga. I think it is, because what's happening, there's like two little spikes, and you can kind of see two little spikes. Like, we can zoom in here and see how there's like this two little spikes thing. There it is. It's A. So, yeah, it's not the best. Yeah, what's up? I'm good. Look for that.
Oh yeah, see that's how it's supposed to.
And then connected lines. Ah, look at that. Perfect. Thank you. That's perfect. I'm going to write that down. Exactly. No, I like that though. That's good. I like that, connected lines. Yeah. Very good. Yep. I like that. Thank you very much. Thank you. That's great. Yeah, that's great. All right, last question. It says, what's the estimate, or what is the estimate of the probability of being stuck by a train? I think this is back to that 20% thing that they were doing above. If you just go back to the 400 value, whatever you put here, I'm pretty sure you're going to put the same number here. So that's all you have to do on that one. All right, cool. Any questions on any of that? Generally, is that okay? So we got a couple more minutes. I would love to go back to the workbook and just do a couple questions here in the next section, because I think we got a roll here. Like we're on a roll. Yep. So addition rule, complements, all this kind of stuff. Let's go through it. See you later. Okay. So complement means opposite. Opposite. Yeah. So if I had said probability of rain is 30%, then the opposite of that would be 70%. Exactly. If I said, probability of getting a baby boy is 50%, then the probability of baby girl would be 50. Total 50. 30, 70. Wouldn't they both equal out to 100? They're opposites, right? 30, 70, 50, 50. Yep, exactly. And then like 20, 80 and all that kind of stuff. So that's the opposites kind of thing. And to be able to do that, the formula is just 1 minus. So let's just say that I had a 0.30, and I say, well, what's the opposite? Well, I subtract it from 1, and then I would get this guy, right? 1 minus that amount. So that's the formula that they're trying to say. All right, but still, I don't know if we're going to use that as much as you think, because what I do normally is just select it over total. So let's go through this. It says, what's the probability of not being 18 to 22? So in a way here, we got our 18 to 22s, but I'm saying not those. So that would be all these selected. And then what's my total? We could, right here, they already did it for us, thankfully. They added everything in there for that one. Correct. We need our selected of adding all those up. Perfect, perfect. And then we're going to divide it by the total they gave us. Very good. See, you know what's going on. That's good. So what I'm getting, so I'm saying the not 18 to 22, I've got 819 selected. And again, what was my total for this whole thing? Grand total. There it is, 975, my total. Calculator, and that would be it. That's all we're doing here. Now, I did not use this 1 minus rule, but I think that this honestly is an easier way to do this in the end. And I always wanted to make it the easiest for y'all. I'm not trying to give you all this theory and stuff. I just want to do what do you need to do to pass this class? This is what I would say. If this was on an exam, this is what I would do. Right? If I'm on an exam and I don't know what to do, that's what I'm going to do. Cool? Cool. Okay, awesome. Sometimes we'll use this little rule, but most of the time not. Okay, phones collected from a conference. We got 1 through 40. So like they're labeled 1 through 40. And they're saying not a multiple of 6. Not a multiple of 6. So like, okay, that's number 1, number 2, number 3, number 4, number 5. Not number 6. Not 6. 7, 8, 9, 10, 11. Not 12. So what I want to do instead of like all those could take forever, I'm going to say, okay, 6 is no good. 12. What other numbers would not be? 18. 24. Love it. 30. And then 36. Yep. And you're right. We stop at 40, so we're good. So I'm going to say not these guys right here. So normally I got 1 through 40. That would be 40 total. But then I'm going to get rid of 6 of them, right? So I'm going to say 40 minus 6. There's 34 of them. So that's 34 selected. What was my grand total again? 40. Put it in and we're done. So I am doing the 1 minus kind of thing a little bit, but more so just kind of like looking at it, you know? So 0.85, that's my probability. Good to go. Cool. So yeah, not those guys. I subtract it from my total just to kind of see, well, how many do I actually have then? And then just divide by total. Select it over total every time. Cool. Okay, I like to physically look at it. I like to physically select things and stuff. It makes it easier on my brain. All right, big topic. Oh my gosh, big topic here. Mutually exclusive. I don't know about this addition rule, but mutually exclusive means that they don't occur at the same time. So let me rewrite that down here. So we got mutually exclusive. They cannot occur at the same time. I'm going to give you some real world examples of mutually exclusive. I want to see what y'all think about this. Okay. All right. I'm driving a car and I'm flying in a plane. Can I do that at the same time? Not at the time of this recording. Okay. Let's do some other ones, mutually exclusive. Can I be sitting and standing at the same time? No. See, I know, right? You're thinking, how can I? Can I be underwater and whistle? Can you chew bubble gum and eat a hamburger at the same time? Oh, okay. That's a challenge right there. Anyways, two things that cannot occur at the same time. You get me? Okay, cool. And if they can occur at the same time, then you're saying they're not mutually exclusive. They're just basically opposites to one another. All right, so they're going to ask, can they occur at the same time? So we got randomly selected somebody owns a car, someone that is a married male. Are they mutually exclusive? No, not mutually exclusive, because you can have someone owning a car and they are a married male. That's like me. I own a car and I'm a married male. So there you go. So not mutually exclusive. So how would I put that here? Like, which one of these makes the most sense? D. Yep. No, because they can occur at the same time. See how they're almost, it's almost opposites. It's almost opposites there. It's kind of weird. It's true that, yeah, they overlap sometimes. Somebody out there owns a car and he's a married male. You're looking at him right here. So there's one. All of a sudden, they're totally not mutually exclusive. Okay. So this is the one that's on the homework. Oh my goodness, and it was confusing to me. It's not hard, but it was just like so many numbers flying around. So we have E and we have F, and they're saying, are they mutually exclusive? So don't even look at S for a little bit. Okay, just don't even look. Just look at E and F. Do they have anything in common? So that's my question. Does E and F have any in common? Right here and right there. So like those numbers. Do they have anything in common between the two? No. Right? We got 14 through 19. The other guy starts up at 21 to 24. So do they have any in common? I would say no. Therefore, they are mutually exclusive. Yep. They are mutually exclusive. The homework question is very similar to that. They ask what the overlap would be if there was an overlap. Obviously, we have none here. So there you go. Cool. Okay. Straightforward. Okay. Now that they talked about that, this is a pretty important topic here, the addition rule. But I'm going to really hone in on a new concept. This is great. I love what they do here. I think it's awesome. But I have a Chad version that is a little bit more focused. Okay, because this is like a little bit more going on. It's pretty busy. So here it is. If you ever see the word or, what they want you to do is add. If you ever see the word and, what they're wanting you to do is multiply. And means multiply. Yep. And that's kind of the basic gist of it. And so you can see right here in the formula, they have the or, and see how they're adding. So that's kind of what's going on. They have a lot more else going on, and we can talk about that later. But for right now, I'm going to say, if they say or, generally add, generally. And if they say and, you're generally going to multiply. Okay? That's kind of the root words there. So let's do this problem here. Actually, you know what? I want y'all to do, this is a perfect you do problem. You do that one. I'll wait. Yeah, y'all do that one. Just the dice one. The other one with the cars, I'll do that one. So this is just a you do. I want to see what y'all get here in a minute. And we're getting pretty close to the end of the class. Like after these two, we might be done. We'll see. Doing ASMR is what I'm doing here. I mean, it's kind of like a joke, actually. I know I'm being weird. Let's do like 10 more seconds. You don't have to finish. I'm just kind of saying, hey, did you go down the same path as me? Or maybe you can tell me when I'm wrong, which that's okay. 5, 4, 3, 2, 1. So we got a 6-sided dice. It says, what's the probability of 1 or a 2? So, okay, I got 1, 2, 3, 4, 5, 6. Those are my options. And I want to physically select them. How many get selected? Which ones get selected? It says 1 or 2. Which ones? 1 and 2, exactly. So how many selected do I have? 2 out of a total of? Done. Yeah, 2, 6. That's okay. That's okay. You're okay. So yeah, I'm just selecting them, saying, hey, those are my entities. And there you go. 2 of them out of 6. It says, what's the probability of less than 5 or an even number? Now we can add this, but really, if you do like a human kind of looking at it, okay? So we got 1, 2, 3, 4, 5, and 6. So first off, let's start with the less than 5. Yep, 1, 2, 3, 4. Love it. Okay. And then I'm going to do a different color here. It says an even number, 2 and 6. And so I'm going to ask you, who got selected at all? At any moment, did they get boxed in? How many actually got selected? 5 out of, perfect. 100% true. 5 out of 6. There's your answer, and you're done. That was all you had to do. All right, let me do this last question, and then we're done for the day. Awesome. Are y'all okay with that? Cool. So Anne wants to buy a Corvette or a Porsche, but she can't buy both. That's okay. It's kind of like, to me, that's kind of like, okay. So if the probability of Corvette is this much, and the probability of Porsche is that much, what's the probability of Corvette or Porsche? Now, here's the thing. We have a probability here, a probability there, and they're totally disconnected. You can't have both, right? And so that goes back to or means add. Just simply put, if I'm kind of lost and I don't know what else to do, and it says or, I'm just going to add them. 100% true. Add them up, get an answer, and we are done with that question. That was all you had to do. Kind of came up to the same number as last time, but there you go. Yep, 8-3, you got it. Yeah, I don't want to do the next one with the cards. It's going to take too long. So is this okay? Good place to stop? Thank you, guys. Have a great weekend.